Hi, welcome back to INST 314, Statistics for Information Science. I'm excited to start with you this next series of videos on basic data management R. R is the software that does all sorts of object-oriented programming, but we're going to be using it for data analysis, bringing in data sets, changing how we use, shape, and analyze the particular data. And in this first video, we're going to get you started on the fundamental first steps of how you bring data into R, move objects around, and just really get started on using this powerful software package. All right, so as we just said in the intro there, that this particular topic is going to be really talking about the fundamentals and getting started in R, particularly for those of you that have not experienced R before and may be new to object-oriented programming. So that we're going to work on entering and loading data into the R environment and the different ways that that stored objects could be worked with, being vectors, matrices, and data frames. So getting started with the fundamentals and foundations, I just use the term object-oriented programming. For those of you not quite familiar with that, that is a way that we can reference storing information into something we call an object that can be used and called upon later by itself or in conjunction with other things. Think of it as saying we take the number 2 and we store it into x. X could be called upon later, and whenever we do, x will reference the number 2. So if you call x, it will tell you 2. If you do x plus 2, it will tell you 4, and so on. So in this case, the first way we can get data into R is to just manually enter it in. We assign values to those objects, such that we could take the term blue and assign it to A. Note here that blue is in double quotes. I could put it also in single quotes, as long as I stay consistent on both sides. If I open with a double quote, I have to end with a double quote. Same thing if I do open with a single quote, I end with a single quote. That indicates some sort of character information, a string, and it's been assigned to the value A. Now in R, I did assignment with the less than dash symbol. I could also use an equal sign. Both will work equally well. And the way I have my code structured here, they're separated by a semicolon. So what is apparently on the screen at the moment is the letter A with the less than dash, blue in quotation marks, semicolon A. Reading that across, I am assigning the string blue to the value A, and then the semicolon just says, I'm done with that, what's next? And it said, show me A, and it prints blue onto the screen. And note, blue has the number 1 in square brackets to the left of it. That is what would appear in R's console when it prints the output and says, this is the first row of the things you've asked me to print, and this is the first object. We'll come back to more of the square bracket with a number in there when we start seeing things on multiple lines. But for now, we can go ahead and ignore it. It doesn't show much purpose. And the semicolon A is not something you have to do all the time. That's just something I put in the code in here at the example to say not only assign the value blue to A, but then print it for me. If you assign a value to an object like A and just run that, you won't get an output that says blue. It's just going to put it into memory, and that's it. You won't see the blue coming out. You'll just be able to reference it later. So moving on, we have B being assigned, the value 5 being assigned to B. So when we call B, we get 5. Below B, we have the object X, and being stored in X is a vector of information, a multiple strings that are being put into one object X. And it's being put in by the function C. Think of C as some sort of way to put together a whole group of things. And in this case, it's blue, 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 red, green. Note they're all in double quotes, separated by commas. And those are inside parentheses put in by C. So when I call X, it tells me that there are 5 colors, blue, 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 red, green. Similarly, we can do it with Y, and we put numbers in this case. And it is possible to create these sorts of vectors with different types of information. We could put them in with a mixture of strings and numbers, but that starts to form a list, and we're really not going to work with lists in this course. But when you work on your data camp activities on the Introduction to R and the Introduction to Data, you will cover lists there. So talking a little bit about a matrix versus a data frame, when we had those values like all of the numbers in Y and all of the colors in X, we called those a vector of data. And when you take those information, it's just one long row or string column, depending if you want to think of it that way. But we can also put it into a bit more of a two-dimensional shape with multiple rows and multiple columns. When that happens, we're creating something like a matrix, a data frame, or a Tibble. The primary difference with some of these, we'll go into them in the next slide, is we're going to refer to them in matrix notation. Let me amend that. You can refer to a vector in matrix notation as well. But we refer to them when we speak in the number of rows by the number of columns. So the image on screen that's an empty matrix, just full of zeros, is a 3x5 matrix where we have 3 rows and 5 columns. Now when we're dealing with a matrix, they all have to contain data of the same type. So all numbers, all strings, something of this sort. We can't mix and match. Those would be for the data frames and the Tibbles. So in the example that I have on the screen here at the moment, we use the matrix function, and I've used 1:8 to indicate I want numbers 1 through 8, integers 1 through 8, to be represented in. I could have equally done a C, parentheses, 1, 2, 3, etc. until I got to 8, close that parentheses. So this is sort of a shortcut. It's followed by the function option nRow saying the number of rows in the matrices, comma, ncol for the number of columns, indicating I want a 2x4 matrix. And note that R automatically fills in this matrix by the columns. 1, then down to 2. Next column 3, then down to 4. And so on moving across. On the next slide, we're going to see how we can change that. But this matrix is being stored into an object x_mat. And when I call x_mat, it prints out the matrix for me. I can use the function typeOf, and it tells me that this is a matrix full of integers. Now the other way I can do this, I'm showing you another example of a matrix where now I'm storing a string values, letters A through H, and I've put them into the C function there so you can show how they're all getting added in together. Note I've added the option into here, by row equals false. That tells the matrix command, don't enter in the values going down the columns, moving left to right. Instead, enter it in, well, the by row, actually in this case, says false because it is entering in the columns. If it had said by row equals true, then it would fill in the values going across the rows rather than down. And note then when I summon the typeOf, it tells me that this matrix are full of character values, where the other one was full of integers. Data frames are a little bit different in that the values inside can be different. Where the matrix had to be all numbers or all characters, the data frame can mix and match. So I've taken x and y that we had from before, I've plugged them into a data.frame function, and that says take vector x and vector y, put them together and into something I'm calling xy. And so when I call xy, it prints out for me, and I see my vectors appear in columns. The numbers on the left side, 1 through 5, are just references to the rows, so I can call row numbers later if I want to use them. A Tibble is like a data frame, but it's a little bit more advanced. So one thing about the Tibbles is that if we look at the screen on the example here, it still tells us we have 2 columns of information containing x and y, but underneath the x and y, inside less than and greater than symbols, we see FCT and DBL. That's shorthand for factor and double. So with a Tibble, we're getting a little bit more information about the variables inside of our Tibble here now. That x is stored as a factor. Note I said it was string information before, but it's being read currently as a factor. And that DBLs were standing for doubles. And the TBL_DF function on XY, which is already a data frame, creates it into a Tibble. Note, Tibbles are part of the dyplr package, which is part of the Tidyverse, and we'll come back to talk about that a little bit later. Now, when I want to pull up this information before, I showed that I could just plug in x and y, and it would give me the entire data frame. But I don't always want all of x and y. I may only want to see a part of it, whether I'm using it for a particular command with statistical information that I want, or maybe I'm using it to reference some additional information. So we call xy as the data frame, but then I immediately follow it with a square bracket, no spaces. And then the first value, because we refer to matrices in matrix notation, same with data frames and Tibbles, if I want to call everything that's in the fifth row, I start with the number 5, comma, and then I don't put in another value. By leaving it empty, I'm saying, give me all of the columns that appear on row 5. And when it comes out, the printed object will say 5, indicating row 5, followed by green, 69, and you'll see the x and y above it to show you what columns they're corresponding to. If I said, give me the fifth row, second column, then I would go ahead and plug in the numbers. So I have xy, square bracket, 5, comma 2, and that shows me 69. Conversely, I could say, give me an entire column of data and not worry about what row it is. So by using xy, square bracket, no value, just leave it empty, comma 2, square bracket to close, I'm saying, give me all of the rows, but give me all of column 2, regardless of what row it's on. So in that case, we're getting everything that was in value y. Another way we can do this is, instead of just referring to just the column and row number by the numbers, we can call them by their values themselves, the x's and the y's. It's a little bit more complicated, but it also allows us to do some other things as well. So in the example here, I'm saying, go ahead and pull up data frame xy, square bracket to do some selection, and I said, give me inside data frame xy, look at the y column, and show me values greater than 20, comma, leave it blank. So that's saying, pull out at all of the rows that have a y column value greater than 20. What we're doing here in this example is something called a little bit of nesting, where we're asking for different operations inside of each other. So we see again below is the same thing as if I was to say data frame xy, select data frame xy's column 2 in the row values that have values greater than 20. And so we can use the column number 2 or call it by y in double quotes, and we get the exact same results. So another way we can do it is by referencing vectors, and this is far easier if you don't have to be as precise with what it is you're referring to. So the way we differentiate a data vector, or treating it like a variable, is with a $sign. I say, look at data frame xy, $sign says, now look inside data frame xy and show me, in the first case, x. It prints out all of the vectors for x inside data frame xy. And it reports back blue, 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 red, green. And underneath that, because it's being stored as a factor, remember earlier when we were talking about some data types, that factors are essentially integers that have oftentimes a text label sitting on top of it. And here it's saying the levels for these are blue, green, and red. The underlying integers, we don't see them. They're there, but they're masked because we've got color terms assigned on top of them. We have tricks to show them later, what we'll talk about. The other one we can do is xy, $sign y, and that says, go ahead and look at data frame xy. And then the $sign says, look inside of that data frame. And then y says, show me all of the values that correspond to the variable y. So let's talk about the attach function. The attach function is a double-edged sword. It can be helpful, it can be harmful, and we need to be cognizant of it. By using the attach function, we put the name of the data frame inside that function and run it. You may get a message that appears like the one on the screen that says the following objects are masked by. You may get a warning that looks similar to this, and you may get nothing at all. You may get a long list, especially if a large data set. Don't freak out. This is just a notice to you, a heads up that says, now that you want to go ahead and call the variables inside data frame xy, you no longer have to reference xy $sign before you type x or y. So if I go ahead and just type x into the console or run it from the script, it tells me blue, 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 red, green. And if I run y, it tells me 5, 13, 42, 28, 69. Now, this is handy and nice, especially if you're running variables over and over and over again, and you're referencing them from the same data set, and it makes your life nice and easy. It can be problematic on two particular occasions. First, if you have objects stored in your environment that have the same name as the variables from the data sets they come from. Remember, we made the variables x and y before we combine them into our data frame xy. And so if I go ahead and just call variable x, I have to be able to know if R is going to be giving me the object x that has those values stored in them, or is it calling x that's the variable that lives inside the data frame xy, as if I was to say xy $x. I'm not sure which one it's printing out for me. I could make them different from each other at some point and take a look and find out, but you might not always know. There could be an ordering issue going on behind the scenes, and you won't know unless you differentiate them enough to find out. And that's kind of playing with fire, especially when you're running multiple lines of code. The other problem happens to be that you can attach multiple data frames at once. And that could be troubling if you have multiple data frames attached where they have variables that share the same name. For example, one of the data sets we will be working on in this class is the GSS, the General Social Survey. If we decide to use at some point the General Social Survey from 2016, which is the primary one you're going to be working with, and another one from a previous year where we might be looking at some different variables, they may share some common ones, like say gender. And if I attach both the GSS 2016 and the GSS from a previous year, and I say, okay, give me the gender variable, R might hiccup and give me the gender variable from the wrong data set. So it's playing with fire. I advise you not to use the attach, but I'm showing it to you so you can be familiar with it and you can spot it out in the wild and when you're working on it. If you have attached something and you want to disconnect it, we use the detach function. Also keep in mind, using the attach or not using it is something that you may experience when you go out to do your internships or you're working out in places and whatnot. There may be coding cultures that have their own opinions in the workplace on your use for using it. So when we want to start loading data into R, there's a few different ways that we're going to work on this. And there are more than what I'm listing here, but these are the primary ones we're going to work on. The first one is where we can actually name an object. That's when you have a file that lives on your computer and we are importing it into R, but it doesn't already have an object name, so we have to assign it one. If you do a read file of this sort of nature and you don't give it a name, it is going to print it out into your console and can make a giant mess depending on the size of your data set, which are often going to be large. So in this case, the example I have on here is the read.csv function, which, as it kind of says, it brings in a CSV file. And typically after that, inside of there, you can put in quotes the directory location of where your CSV file is. You can identify your working directory and call it from there, or you can type out the long file path on your computer, and it will go get it. There's other ways we can use that as well, but that's like searching from the internet and things like that. You may cover that in some of your data camp labs, but we're not going to cover that here in class at the moment. However, using another option, file.choose, followed by an open and close parentheses with nothing inside of them, is sort of a shortcut method. This allows you to open a dialog box on your computer when you run the read.csv function. It opens up a box and says, okay, go navigate on your computer to where your CSV file is at. It's a fantastic way, especially if you're sharing script files and your CSV file may be putting in different directories, or you've moved it because you're organizing files on your computer, etc. It doesn't work sometimes if you just want to run everything from start to finish, because then it interrupts your run period because you have to go look for the file. So there's ups and downs to everything. It's followed by the header equals T option, which means header equals true, which is the option by default. So if you don't include header equals T or header equals true, it's going to run that by automatic. And what that option means is the very first row of your CSV file contains your variable names. And so if your CSV file does not contain variable names at the top, you want to make sure you include header equals F or header equals false. And then, of course, we are assigning this to whatever name you want. I've typed name in all caps, but it's completely arbitrary. You can call it ABC if you want it. Doesn't matter. Another way we can get data into R is using a load function. And the load function, note I'm using the file.choose on there again, which opens the box to navigate to find the files I want. The load function is specific for .r data files. So these are data files that have been stored in R or created in R and saved natively, and this will pipe them in. Note with a load function, we do not add an object name. It already has one because it's been saved in R with it. If you try to assign a name to it, it might hiccup. If you try to use a load function on a CSV file, R's going to hiccup. It's going to import it. Most of the time, at least, it will import it. You might not notice the difference, but it's going to be messed up. It's not going to have all of the columns and other things, and you might start freaking out wondering where your data is, and just recognize you used the wrong import function. Another way that we can get data into it that we're going to work on is using a data function. R has data sets built in. When you install it, it brings some in. Others are part of packages you're going to be installing later, and the data function pulls those data sets into your object environment for you to work on later. Now, I just mentioned packages and libraries. For those of you that aren't quite familiar to these sorts of concepts, go with the understanding that base R refers to when we install R and RStudio onto your computers, you get a suite of different functions like read.csv and load. And so we come with a toolkit already. Packages are extra collections that people have written, put out on the internet, and that we can go ahead and install on our computers. They typically contain more functions and data sets. Could contain other things, but that's predominantly what it's going to have. Once you install those on your computer, you're good to go. It's going to stay there until you either wipe your computer or you make some other sort of major change, or maybe you uninstall R and you need to reinstall it later for some reason. Libraries are when you take the packages and you activate them on your computer, on your RStudio. And the difference between the package and the library is when you install the package, you're done. But the library, you need to run that every time you boot up R or RStudio. Think of it like a room with a light switch. You turn on RStudio, your room is dark. When you want to use that particular library, you flip the switch up with the library function, and it turns that package on. And at that point, you can go ahead and call the functions and data sets that might be in there. If you don't have your library run and you try to run a function that's from them, you're probably going to get an error message. So you just need to make sure you have that. Note in the example I have at the bottom of the slide, I have the functions as we would use them in R. There's install.packages. And notice that I put the name of the package inside quotes. It could be single quote or double quote. It's required for that line. But when I use the library function, I do not use any quotes. So just briefly, here's an example of using the data function with housing. On the previous slide, it was part of the ecdat package. So we installed the package ecdat. We used library on ecdat. And now from there, we can use the function data housing to import a data set about housing information that was stored in the ecdat package. We can look at it inside R using the sort of spreadsheet sort of view with the view function. And note, the view in this case is capitalized. R is a case-sensitive language, so capitalization matters. And sometimes there's just some functions you're going to have to remember which ones are capitalized and which ones are not. And when you get error messages, that might just be a reminder of which one you have to deal with. So when I run view on housing, this is what it shows me. In RStudio, this is going to appear as a tab up at the top by my script file that I can just navigate between. And we see in the columns, it has the names of the different variables inside housing, such as price, lot size, bedrooms, and so on. And then going down the rows in the dark bold, that's just a row number indicator. And then we have our variables inside of them. At the bottom of the screenshot here, it says showing 1 to 11 of 546 entries, which means we are looking at 11 different columns of 546 different observations in this data set. Using another example of the load CSV, we're using a CSV file and the file.choose, And I have a note on here that we're importing a CSV called movies.csv. This file actually contains Netflix movie data. So I'm calling it and storing it into an object I called Netflix. I could have called it N, I could have called it movie, whatever. I chose Netflix because it's Netflix data and I wanted to be reminded of it. I use the view function on that, and it shows me a very similar sort of spreadsheet where I have the different columns containing variables such as budget, company, country, director, etc., and different rows, one for each particular movie, and then there's the data points in there as they are. Note when you use these view functions and it opens up an extra tab in your RStudio, you will have to close those individual tabs when you're done looking at it. Now when I want to add a new variable to the data set, there's a few different ways that we can do this. So the data set's already loaded, whichever method we've used it to put it. Once it's in the object environment, we can start manipulating it, working with it a little bit. So at the moment, what I've done in the examples here is I'm creating a new vector just full of true and falses. So I use the C, and inside there, T, F, T, T, F. So I've made a vector of 5, length 5, with a bunch of trues and falses, and I'm storing that into something called Z. I still had in the memory here X and Y, which had the colors and the numbers. And in this case, I'm using a function called cbind. Think of it as being short for column bind. And I said cbind data frame XY, Z. So I'm saying print out XY, and then on the end of it, on the right, add in Z. And if I was to run XYZ, which we would see at the bottom, it would print out column X, column Y, and column Z. Now I've added on a couple things into the screenshot here, so let's go back up and look at what else has been added. On the third row of the examples, I've taken the column for the variable Y, and I've squared it with a little up caret 2, and I've called that a new data vector, y.sq, just to be short for y squared. And again, I've done a cbind on that, so I've taken cbind with the xyz, and I've added y.sq. Another way we can add things into the data frames are directly attaching. I showed you cbind where we're attaching column by column. But there's another way where I said before, when you want to call a data vector, you can call it out specifically with a $sign. And you can use this to make new columns. If I say a data frame XYZ, $Y2, and if Y2 doesn't exist, it will create column Y2 at the end. So in this case, I've done 2 times Y, and that is taken the column Y, multiplied it by 2, and I'm assigning it to a new column called Y2. So now when I call XYZ, I see my X, my Y, and my Z, but I'm also seeing Y.sq for the squared values and Y2 for the Y times 2 values there onto everything. If you ever need to get help and kind of remember how some of these work, or even the functions we haven't looked at yet, always just keep in mind inside the console or the script file, or, well, the help section is a little bit second. So if you're calling it from the command line, it's a quotation mark followed by the name of the function without the parentheses, and it will open up the help menus for you. However, RStudio also has another advantage of using RStudio over R. In the lower right-hand corner, unless you've repositioned the different quadrants of R, which you can do, there is a tab called Help. And there's a search menu up there so you can actually look for data frame, and it will show the data frame command. And you can scroll down through and see all sorts of options and sometimes example codes. Sometimes the help files are informative. Sometimes they're a little enigmatic. So feel free to let me know if you have any questions about the help files when you're looking at them. So just lastly, before we wrap up, I want to just briefly mention the dyplr that I had said before and the Tidyverse. The dyplr is a package which comes with a bunch of data management functions. However, the Tidyverse is in reference to several packages which tend to work together, and it's designed to give you additional functions and code practices that are supposedly cleaner, more intuitive, easier to work with, and really help you shape the coding culture and strategies that you're using. It's becoming a very hot topic in data sciences, and so a lot of people are using towards it. In your data camp extra credit works, there is a short course on Introduction to the Tidyverse I will recommend to you. We're not going to use a lot of Tidyverse specific functions in this course, but I think it is something that's good for you to know, especially if you're going to go into the data sciences. And with that, this was a bit of a longer video. Thank you for keeping with us on this, but I'll see you in the next one where we dive a little bit deeper in.